Okay, this is a series question. It's from our formal homework. So let's take a wee look. We need to find the sum between 3 and n of r squared plus r plus 1. So I'm going to split that up into its 3 different parts. So I guess my first line here would be, I think then that is equal to sum between r equals 3 and n of r squared plus the sum between 3 and n of r plus the sum between 3 and n of 1. Now that's a bit of an odd one, but we'll chat about that in a wee second. So it's the sum from 3 all the way up to n. If it's the sum just up to n, we have a wee formula for that. We're going to use it a little bit later on. But we need the sum. If we're going from 1 all the way up to n, we've got 1 and 2 there, so we need to take away those. So I'm going to split each of these up into 2. So this is going to be the sum of r equals 1 up to n of r squared plus the sum of r equals 1 up to n of r plus the sum of 1 up to n of 1, and then we need to take away from that the sum of r equals 1 up to 2. We obviously don't put 3 in there because we want 3 to be in it, of r squared. Take away the sum of r from r is 1 to 2. Take away the sum of r equals 1 to 2 of 1. Our formula for this one here, in your formula booklets, 6 of n plus 1 upon 2n plus 1. The sum of this one here is a half n plus 1. The sum of all the ones from 1 up to n, so it's going to be 1 plus 1 plus 1 plus 1. So how many of them are going to be? It's going to be n, so plus n. The sum of the square numbers from 1 to 2, that's just 1 squared plus 2 squared, which is going to be 5. So I'm then taking away 5. The sum of the numbers, so it's 1 plus 2, so let's take away 3. And then there's going to be 2 of these. If you kind of look back up to the original question, you sub in the number 3, and so there's going to be a 1 there. Sub in the number 4, there's going to be 1 there. So here there's going to be 2 of these. So we end up then with that. That's going to give me, let me see what's my best way to try and work this. Right, if I go with 6 n plus 1, 2n plus 1 plus a half, and then I have this multiplied out, n squared plus n, and then that's plus n. Take away 10. Hopefully you're still with me. That gives me, let me see what way I'd want to do that. If I just multiply that out, maybe a 6 of n, and then that gives me 2n squared plus 3n plus 1 plus a half n squared plus n plus n. Take away 10 and then just take each term. This times this gives me a third n cubed plus a half n squared plus a sixth n plus a half n squared plus a half n plus n minus 10, and we're aligned from the end here. Just join together all my like terms, so I get a third n cubed plus 1n squared, because we have a half n there and I have a half n there, so it's my 1n squared plus 5 over 3n, I think, whenever you join those together. Take away 10, and that's our answer then to the first one.